Good evening, this is Mr. Win bringing you Unit 4 Lesson 2a here, and in this lesson you are going to begin graphing systems of equations. So taking a look at the first one here, we have a sketch the lines given by x plus y is equal to 6 and negative 3x plus y is equal to 2. So all we're going to do here is first rewrite these so that they are easier to graph here. My first one, x plus y is equal to 6, I'm just going to set that as y equals negative x plus 6, just so that it's in our y equals mx plus b form. So then my other one becomes y equals positive 3x here plus 2, just moving the x's there so that they are in y equals mx plus b. So now that we have it in y equals mx plus b, we can start to graph these here. My first one is negative x plus 6, and that positive 6 there just tells me that I start at 6 here. And the negative x there is how I'm moving, or my slope. So down 1 over 1 here. And I'm just going to draw in my line here. So then my next one here says to start at 2 and to go up 3 over 1, up 3 over 1. So then I'm going to draw in that line. So if we're looking at our two lines here, notice that they intersect at one point here. And that point does have the coordinates 1, 5. Next, we're going to solve it algebraically here, and it is a little easier to solve this one. Notice that you can use substitution. So if I use substitution here, I have negative x plus 6 is going to be equal to my other y equals there, so equals 3x plus 2. So if I'm solving for x here, I can move the x. And since I moved the x, I'm going to move the 2 here the other way. And that will cancel there. And 6 minus 2 there will give me 4 is equal to 3x plus n. X there will be 4x. So then solve for your x here. And we get x is equal to 1. So if I go ahead and plug that back in, I get 3 times 1 plus 2 is equal to y. So 3 plus 2 here is going to equal y, so y is equal to 5. Which, from what we saw with our graph here, is going to be our coordinate points where they intersect. So let's take a look at part B here. So in part B, it's asking you to graph the second line as x plus y is equal to 2. Let me just rewrite our first line here. We had the equation y equals negative x plus 6 here. And my second equation now, again, just rewriting it so that it looks like in y equals mx plus b, it will become here y equals negative x plus 2. So again, my first one there is just starting at 6. And my slope tells me to move down 1 over 1 here. So if I get a line going there. And my other one tells me to start at 2 with the same slope here. And I'm just going to draw in that line. So notice with these two lines here, they never intersect, and these two lines here are parallel here since they share the same slope. And we can check this algebraically if we set the two equations equal to each other here. So we have negative x plus 6 is equal to negative x plus 2. Since they are both in y equals, we can't just do our substitution here and plugging those in. So notice that if I move the x here, plus x, and plus x here, the x's here will cancel. So you are just left with 6 is equal to 2. And since 6 does not equal to 2, this tells us that the two lines are parallel, that they're never going to intersect. So let's take a look at question C now. In part C here, we're going to replace our second line there with 2x is equal to 12 minus 2y. So let me rewrite our first line again. We have y is equal to negative x plus 6. And my other line is going to be 2x is equal to 12 minus 2y here. And since they all do share a 2, I can divide out the 2 here and divide the 2 and divide by 2. So I get x is equal to 6 minus y. And since again I want it in y equals mx plus b, I'll subtract the 6 here and I get x minus 6 is equal to negative y. Just dividing by negative 1 there. Divide by negative 1. And I'm just going to rewrite this down here as y is equal to negative x plus 6. So notice right away that our two lines are going to be the same here. We have y is equal to negative 6 down here and up here as well. So if we graph these here, we have starting at 6 here. And again, our slope just tells us to move down 1 and over 1. So if I draw on my first line there, and I'll change color for the other line. Again, it's going to be the same line, so really I can just put these in right away here and just trace that line. So this tells us that all of the points on these two lines here are going to intersect, and it just tells us that there are infinitely many solutions. So if we check this algebraically here, we have y is equal to negative x plus 6, and that is going to equal our bottom equation down here, negative x plus 6. So notice that if you add the x over here and add the x, you get 6 is equal to 6, which is a true statement, and that tells us that there are going to be infinitely many solutions. So last question here, let's take a look at question D. So we've seen that two lines can intersect at one point, no point at all, or an infinite number of points. And they're asking if there are any other possibilities. And if we draw out each one here, so these two lines will intersect at 1 point. And we have two parallel lines here that will intersect at 0 points. And the last case here where it's the same line that are overlapping here. They intersect at an infinite number of points. And hopefully you see right away that there are no other possibilities. These are the three possible cases here. So the answer here is just going to be no other possibilities. That's it for this lesson. If you have any questions, please bring them to class. And as always, thanks for watching.